Hello, everyone, and welcome to the Weekly Space Hangout for Wednesday, October the 11th, 2017. I'm Fraser Kane, publisher of Universe Today. This week, we're going to be talking about the discovery of all that missing matter, the news that we pushed forward a week about the finally an answer for Tabby Star, maybe, and NASA's plans to go back to the moon. Joining me this week, we've got two of our regular co-hosts. First up, Dr. Kimberly Cartier. Kimberly,
Hi,
welcome.
Fraser. Hello, world. Good evening. Happy Wednesday.
And we've got Dr. Paul Matsetter,
The other guy.
the other doctor. And we're missing our third doctor. So it's still Fraser and two doctors. So,
He's here with us in spirit.
Yeah, exactly.
He's not dead.
he's
Just to be clear.
He's just fine. He's sciencing out there somewhere, and we'll find him. We'll find him next week.
He's up to something.
All right, so let's get into the show. Well, actually, before we get into the show, I just want to remind everyone that this show wouldn't be possible with the dedicated support of the Weekly Space Hangout crew. This is, of course, the executive producers of the show. Go to wshcrew.space. There's all the instructions. You can join the community, and by doing so, can participate in the behind-the-scenes chat where many more than 100 people now are sort of involved, talking about space, talking about the news, talking about the show, planning future guests, and really kind of the heart and soul of what we're doing. So thanks, as always, to the WSH crew. We could not do this without you. And for example, today's guest, completely organized by the crew. So, all right. I choose Paul, because you're on my video right now, to tell me about the discovery of some missing matter.
Yeah, exactly. Now, to be clear, we all need to make sure we're all on the same page. This news story about missing matter is not about dark matter. I've seen a lot of confusion among even some journalists and especially commentators, people on message boards and blogs and social media and all that. This has absolutely nothing to do with finding dark matter. This has to do with finding what we're calling missing matter, as a more technical name, which is the warm hot intergalactic medium, or WHIM, W-H-I-M. And the issue here, which we've had for a few years, is that based on other measurements, and it's up to you guys if you want me to get into those other measurements, we know how much normal matter has to be in the universe. We know how much hydrogen and helium and all the other stuff has to be in the universe. But when we do a census of all the galaxies, all the galaxy clusters, everything we can spot, we only see about 10% of that number. So we know there's more out there, probably between and around the galaxies, because if it's not in the galaxies, it must be between the galaxies. But we've had a hard time spotting it because it's spread out over such a big volume, and it's very, very thin, and it's hard to spot things like that. And there were two papers that came out simultaneously, and the author groups knew that the other group was working on it, and so they both reference each other. It's actually complementary surveys, complementary techniques, so this leads it some credence. What they did was to take galaxy surveys, current galaxy surveys from the Sloan Digital Sky Survey, map out all the galaxies on the sky, then pick out galaxy pairs, pick galaxies that were close to each other in space, then project that onto, of all things, the cosmic microwave background. With the cosmic microwave background, it's acting like a backlight. It's silhouetting all these structures, all these galaxies. And as though that microwave light passes through the galaxies and it passes through the gaps between the galaxies, you get an interesting effect that has the wonderful name of the Sunyaev-Zeldovich effect. It's named after two Russian scientists who figured this out. And you have low energy microwave light coming in from the CMB. You've got a hot gas that's bouncing around all crazy. Every once in a while, one of those electrons can slam into that low energy light and make it scoot off, going really fast as a nice bit of high energy light. So we see these as little hotspots. We can actually use this technique to pick out galaxy clusters in the CMB itself by looking for these little hotspots.
So like you could see them, you could detect these galaxy clusters without being able to see them by just sensing it from the CMB.
Exactly.
And so like once again, is there anything that the CMB can't do?
It cannot wash my clothes, even though I've tried.
Find
Because it's
exoplanets?
We just don't
Find
have.
exoplanets, that might be a little bit challenging too, I guess. Although maybe there's some lensing. There's a little lensing. Anyway. So yes, we can find, and this is actually a really useful technique for finding distant galaxy clusters, ones that are too far away to find with telescopes with optical or even X-ray instruments, because they leave essentially a little shadow, a little hotspot on the CMB. So this technique, what these researchers did was look between those galaxies and stack up. They found like 1 million pairs in one paper and 250,000 pairs in another paper, and stack up all these little weak signals, and they found evidence for this Salyut-Zeldovich effect, which means there's hot gas sitting between the galaxies, and that you can estimate the amount of mass that's sitting between these galaxy pairs, and they peg it at around 50% of the missing matter.
So that doesn't answer where all the matter is. That just answers where 50% of the matter is.
It gets us somewhere. Presumably, the rest of the missing matter is spread out even further. Maybe there's some sprinkled in the voids, or there's some thin filaments and sheets. This focused on the gaps between close pairs of galaxies, and just those gaps are apparently enough to account for about half the missing matter.
Huh. So based on that, then, do you think that it is that gas will account for the missing matter? We don't have to get to anything exotic. It's going to be missing.
Yeah,
it's going to be this missing gas in the supervoids.
Right. We have not exhausted the mundane explanations for where the missing matter might be. We know it's very challenging to get observationally. This is a very, very difficult measurement. And just the fact that we were able to get half using this trick from the CMB is a big deal. And maybe we can use similar tricks to go after some more diffuse sources of this matter.
So did we know that this intergalactic hot gas was there before, and it's just we didn't know how to measure how much of it was? Or is this a new discovery of we didn't know this gas was there?
We figured it was there because simulations, theoretical calculations suggested that's where it ought to be. And there have been previous attempts at measuring the warm, hot intergalactic medium that got some of it, a few percent here, 10% there, and hinted that it might be in this filamentary structure between the galaxies. This is the first solid piece of evidence of where it might lie.
Okay. You think that there's even more than just the 50% that they found? And the Salyut-Zeldovich effect is only getting us the 50% then?
That is a good question, because it depends on the magnitude of this Salyut-Zeldovich effect depends on the temperature of the gas. So with a given sensitivity threshold, with a given level of what you can measure, you can only measure a certain range in temperature of this gas. So if the gas happens to be a little bit cooler, you're just not going to see it because you don't have the sensitivity to pick it up. So you're right, in those filaments, there might be even more gas that we're just not seeing because it's not giving us that Salyut-Zeldovich signature. Or we may have accounted for all the gas in the filaments, and the rest of the missing mass is somewhere else in the universe.
A couple of questions here from the audience. This comes from Arjone. Will this gas be able to fall into galaxies and make stars, or is it too hot?
Right now, so galaxies do accumulate matter over their lifetimes, and these filamentary structures between galaxies do tend to flow on into galaxies. The densities here are very, very low, so I doubt you'll get increased star formation, or if it's enough material, it's more like a drizzle instead of an impact where you get additional star formation. There's additional mixing physics, especially in galaxy clusters. You can have winds driven by supernova coming out of galaxies that blow off this warm, hot medium. You're certainly not going to get star formation in the filaments themselves. They're not nearly enough high enough densities and low enough temperatures, but it does contribute to the overall accumulation of matter in galaxies over the course of billions of years.
Right. All right, moving on.
Cool.
Yeah, I've actually done a ton of articles on this missing mass, and it's hard to make that. You have to remember that we're not talking about dark matter. We're talking about regular matter that's missing.
It's always been missing, regardless of dark matter.
It's always been missing. But how did astronomers know that it was missing and that it wasn't dark matter? How did they know it was missing but regular matter?
We know that we know the total amount of normal matter in the universe through a couple techniques. One is Big Bang nucleosynthesis. We've been able to predict, based on nuclear reactions happening in the first 20 minutes of the history of the universe, we're able to predict the ratios of hydrogen and helium and lithium and other elements, lighter elements in the universe. And the only way to match the ratios that we observe is you have one little free parameter, which is the relative amount of radiation to normal matter. So if you fit observations, that tells you, bingo, how much total normal matter has to be in the universe. So that's one source of, now we know how much total stuff there is. The second is from the cosmic microwave background itself, from the statistics of that afterglow from the Big Bang. If you put a bunch of ingredients into the early universe, like normal matter, radiation, neutrinos, dark matter, whatever you want, that affects the structures that you're going to see in the CMB. And by looking at the structures, you can figure out the ingredients of the universe. And that provides an independent line of evidence telling us that the total amount of normal matter. Plus, you have simulation works of large-scale structure that only match observations if you know the total amount of matter. So we have multiple independent lines of evidence that tell us how much normal matter is in the universe, or ought to be, and then we just can't find a good chunk of it.
Right. Kimberly,
Yes.
let's talk about, finally, an answer for Tabby Star. Turns out, not mega structures.
No, it's not.
Really?
So I'm gonna still figure out some way to sneak him in there somehow in the explanation. You'll see. I'll figure it out.
All right.
So in the ongoing saga of what WTF is going on with Boyajian's star, or Tabby's star, there has been a new paper that came out that presents fairly compelling evidence that what is causing it, at the very least, what's causing the longer term dimming that we've seen through the Kepler mission and hints of through photographic plate archives, this long-term dimming effect might be caused by a large cloud of circumstellar dust in approximately a 700-day orbit around Tabby's star. If you recall back a few months ago, this was still one of the potential theories that could have explained both the dimming and those really sharp dips that Kepler observed and other people have observed around the star. And what everyone has always been saying is we need to get measurements of the dimming and the dips using multiple wavelengths, because when you do that, you can figure out what's causing it. And that's exactly what these people did. They were able to measure the dips and the dimming of Boyajian star in ultraviolet, in X-ray, in visible, and in infrared. So essentially a good chunk of the electromagnetic spectrum. And what they found is that the ratios of how much the star is dimming in infrared compared to how much it's dimming in ultraviolet are very consistent with the type of dust we normally see that results from like planetary collisions or asteroids colliding, this circumstellar dust or debris disk. It's not consistent with the type of dust we see between stars. It's not consistent with a large planetary structure or an alien megastructure or anything like that, any of the other more esoteric things that we've suggested over the past few years. But it is very consistent with a perfectly ordinary large cloud of dust on a large orbit. However, I will give the caveat that they're still not able to explain some of those really large dips. If you recall back in the Kepler mission, when 20% of the light of this star was taken out over the course of about 2 weeks or so, and then abruptly came back. And there was a similarly large event back in June and again back in August of this year. So the theory of large cloud of dust can't explain everything, but it does give a very compelling set of observations to explain at least the longer term dimming over the course of the Kepler mission. So, partial answer.
Right, but I look at this picture.
Partial.
Yeah, I mean, I look at the pictures and sort of the mock-ups of what could be going on here, and it's like a, like an uneven, like an arc of dust that's going around the star, and so I guess as this dust is coming in between us and the star, then it's dimming a bit, and then it sort of, the arc goes around, and then it's got a clear view, and so it brightens up.
Right. So
what wouldn't that be? Shouldn't that turn into a sort of evenly distributed belt of dust around the star?
It could potentially, given long enough time and stable enough gravitational field, but we don't actually know what else is going on in this system. This giant cloud of dust might be the result of a more recent, in the past million years or so, type of collision event between who the heck knows what. It could have been an alien megastructure smashing things together. See, I know I
did it. Yeah, way to go.
It could be, just a normal planetary or protoplanetary collision, or asteroids or comets, or any type of collision that causes debris disks that we see in other stars. We don't actually know what else could be going on in this system or how young this cloud is. So maybe over time it could even out, but one of the defining characteristics of Tabby star is that it's always been irregular. So at the moment, at least, if the cloud is there, it has to be sort of clumpy and oddly shaped in order to be able to explain the types of observations that we see.
But
it could, and it gives more credence to things like there could be a swarm of comets that are causing sort of the larger dips. That's comets and dust clouds go very well together. So,
but it's clear that this is very unusual because we haven't seen a lot of these out there in space. This is the first time we've seen a star with this kind of behavior. So,
are there any stars like Voyager's star that have that we've seen through Kepler that have big dips in brightness?
Not like this. Not like this. There hasn't. There's been people have looked through the hundreds of thousands of Kepler stars that were observed, and there has been no star that has these kinds of dips with this strength and this irregularity that we've seen with Voyager's star. So whatever is happening, it's rare, and likely it doesn't last for very long. Because even if it was rare, if it lasted for a very long time, we'd expect to see more of them because they'd be around long enough for us to see. So it's rare. It's probably a short-term event, and we're just lucky enough to see it.
I'm sure the last time that we talked, I probably asked you a question, something like what would it take for you to get to the bottom of this mystery? And you probably would have said something like, I'd like to see it in a bunch of different wavelengths. I'd like to see it in infrared. I'd like to see it in visible. I'd like to see it in...
I think if you go back to June, I said all those things.
I'm sure that was our conversation. Yep. So here we are, right?
Yes.
Those observations have been done. A much better answer has been supplied.
Yes.
What would you like now? Would you like a survey of other stars to look for this kind of behavior? Is there some other kind of data that now can be gathered that will get even closer to the answer? What would you want to do?
Sure. So I'll tell you what I am convinced of right now is that it is some form of dust within the Voyager star system. I'm convinced that there is dust there that is causing some of this dimming and possibly some of the dips. The fact that they predict a cloud on a particular orbit means that eventually, a few years down the line, it should come back. So what I would like to see is, I'd like to test out, this prediction and say, given what we know, when these dips happened, when is the next time they should happen, given this orbital period? Let's all swing our telescopes over there then and see if it's actually happening. With Kepler planets, you need to see transits at least 3 times consistently to know a planet is there and it's not something else. So if this is a stable-ish cloud on a particular 700-day orbit, I'd like to see these types of measurements done a few more times, just to verify that this is what's happening. And I'd like to be able to still explain those 20% dips that this giant cloud theory cannot explain still.
Yeah.
So part of the puzzle, it gives us something predictable and testable. And so I'd like to see that test done, and then you might convince me. We'll see.
Well, I don't know if I'd be the one that would convince you, but
You'd probably get me to say something, I'm sure. Someone mark this time.
Yeah.
I will say Fraser may be able to convince me a couple years from now.
that it's an alien megastructure.
Stop.
Yeah. No, even I no longer am excited about that idea. I don't care. Whatever. Aliens,
You
dust.
were excited?
I was. No, I
Come on.
Well, I'm also going to take this time to reiterate that us people who wrote about the alien megastructure never actually claimed that there were alien megastructures over there.
couldn't.
I'm going to repeat that
You
again.
couldn't for sure rule it out, and that's
You
all.
And
were
now we
waiting.
can.
That's
Now
all
we
that we
can.
needed. It was
I
all-
read your paper, Kimberly, and you were totally winking. Like every
Yeah. Yeah.
I'm
Whatever.
also-
Whatever's the
you know,
latex
okay,
winky face, you did
the
it.
History Channel. I'm not saying
It was
aliens.
commented out.
Yeah.
I'm not saying it's aliens. But
Yeah. It's right there in the latex code. I
But you
know it.
know what? Now we can actually rule it out. The infrared and UV light are not consistent with something big enough to be an alien megastructure unless it's an alien megastructure a couple microns wide.
All right.
So
All right. I'm fine with the dust idea. Dust.
dust to dust.
Yeah. That'll be our secret code.
Did we
I'm
lose the Kimberly?
she's definitely I don't know if we can hear her still.
She got mad.
I can still hear all of you.
Okay, you're frozen on the
My
screen.
web is frozen, but I
Yeah.
can hear all of you.
Okay,
And
well,
apparently you hear me.
That's fine then. Then I get to tell my story of the week, and this is it. It's official. We're going to the moon. So on October 5th, Vice President Mike Pence showed up to the, I don't know how to pronounce this properly, the Udvar-Hazy Udvar-Hazy Center, yeah, and stood in front of the space shuttle. Man, like, one should always give speeches in front of the space shuttle, because that was awesome. And said, hey, we're changing the plans. We're not going to asteroids into Mars, as the previous administration had hoped. Now we're going back to the moon. And that was literally as much information as we got. He had a couple of things to say. Let me give you a couple of quotes that he said. We will return NASA astronauts to the moon, not only to leave footprints and flags, but to build the foundation. We need to send Americans to Mars and beyond. So the thinking right now is humans to the moon somehow. And then once humans have learned to be on the moon, then it's humans to Mars. Now, if you recall the last couple of episodes of the Weekly Space Hangout, I mentioned that the Russians have come on board with the development of the Deep Space Gateway. So because of the sort of the closeness of these announcements, I'm going to assume that the Deep Space Gateway, which was developed under the Obama administration, is still going to move forward, but now it's going to have some Russian components. But Pence also put a lot of emphasis on the possibility that private industry is going to play a much bigger role in what happens with NASA's plans. So the sort of this announcement that Pence did was sort of the beginning of a special group that they were going to be putting together. I forget what they actually called the group. The National Space Council. So they're calling it the National Space Council, and it consists of a whole bunch of people from NASA, people from government, people from private industry, and they're all gonna hash out the details of this. And of course, And make it happen. Yeah, exactly. Just make it happen. And then this falls under the, as we all recover from Elon Musk's announcement that the BFR is totally going to the moon. It's going to be able to land. It's going to be able to return for less than the price of a Falcon 1. So here's where we are right now, which is,
So
I don't know.
we're not going to
Yeah.
Mars anymore.
No. No. Are going to Mars after the moon. So moon first, then
Again.
Mars.
Okay, so I've been telling kids like who are 10 years old, I say, you may be the first person on Mars.
I
Now I
would.
have to tell them you may be the first person back to the moon.
That's right. Yeah. But that's not true because, the Chinese are working on their moon missions. They sent the Chang'e 3 lander and the cute little rover that was there. They've already tested their lunar return rocket, their sample return rocket. They're going to be sending a sample return in 2019. It could very well be that it's the Chinese that are the next people to return to the moon, unless, of course, everyone stays at the SpaceX hotel,
Right.
right? Which should be going up in I don't know, next week.
Something like that.
Yeah, something like that. So
Pence announced that they gave no timeline, any reasonable estimation of when we would go back to the moon. This isn't like we're going to go in the next decade, not because it's easy, but because it's hard
no,
thing.
no. The gist is it's next, right? And there are no details because they are beginning the National Space Council to figure out how this is going to work. And like, this is classic, right? I mean, this just like, oh, what a surprise. The current administration canceled the plans of the previous administration. That is literally like the force of gravity that goes on. You can expect this every single time, is that the current administration is going to cancel the plans of the previous administration, and the next administration will cancel the plans of the previous administration, and every time you need to go to a new destination. So really, we're just going to, we've gone moon, Mars, moon, Mars, moon, Mars.
There was an asteroid in there somewhere.
There was an asteroid.
Yeah, well,
Yeah,
really,
we were going to go to an asteroid next,
yeah. So, and just to be like
which
really,
I was excited for, but
just to be like really specific about this, right? President Bush, the first Bush, said that they're going to go back to the moon and then on to Mars with this fairly expensive thing that got canceled by President Clinton. Clinton started to put together. Actually, Clinton sort of didn't do any sort of bold plans for what they're going to do. They just kept going with the space shuttle and building the International Space Station. And then the George H.W. Bush, he put together the Constellation program and said that, in 2006 that they were going to be going to the moon. And then Obama canceled the Constellation program and made it the Space Launch Systems program with the Deep Space Gateway, and they're going to go to the asteroid. Now that's gotten canceled. So here we are. And once we have details, I'll totally announce them.
and then retract them a few years later.
But yeah.
Hey, we always got something to talk about on the Weekly Space Hangout.
Yeah, exactly. And I've railed about this, and, perhaps I shouldn't be providing my opinion, but I'm going to, because, you guys do, which is, I'm really a fan of this idea of the capabilities-driven approach, which is where you don't pick a destination, you just make every iteration of what you can do better than the time before. Go farther, keep humans alive in space longer, a rocket with more delta V, each step just a little more capable, and then no one can cancel your plans.
But is trying to make all of those innovations without actually announcing a destination actually feasible or reasonable? I feel like you have to give someone some sort of lofty goal in order, by someone I mean Congress people, some sort of lofty goal to aim at, to get them motivated enough to give funding for these programs.
Except they've tried that, right? I mean, I mean, yeah, I guess so. Yeah, and they get motivated, and then they
You
cancel
can't
the
just say
plans.
we're going to build a bigger, better rocket to go into space
Yeah.
a week longer than we did before. That
I mean,
doesn't inspire.
and yet that's what would take them further. But
That's
I mean, it's like
that's the practical outcome,
right,
but
each administration is more outraged by the length of time it's taken for humans to return to the moon. Like that's the thing you can count on. And so now it's 45 years or 50 years or whatever, right? And we'll just
I
keep
mean, you
going.
can
Then
also
it'll be
count on everyone being outraged that James Webb isn't up yet,
yes, yes,
but that too.
yeah,
So
maybe
I'm surprised.
astronomers.
So the normal reaction would be like, okay, let's turn to the private companies who can focus on a singular vision and just commit and go for it, and who cares about who's president. But now we have SpaceX seeming to focus back on the moon too. Is that in response or anticipated response to the pivot in NASA to focus back on the moon?
Yeah, well, so this is a big thing, right? Is that originally Musk had sort of anticipated that the space agencies would be the ones, and the interview will sort of go into a lot more detail on this, but that the space agencies would be the ones that were going to do this. But it was very clear that this just wasn't happening, and so he decided that he needed to build a rocket company to actually move human beings to the next step. So. Yeah, I think the thing that will be unusual about this iteration, if it does happen, is there could very well be a very big investment or of privatization, of going, well, you know what, if the BFR is going to actually function as planned, then let's just start pushing some of that capabilities out onto them. But the problem is that there's a ton of people employed by NASA, a ton of people working on the SLS. The whole reason of the SLS was that it was a way to take NASA to the next step and not have to fire and lay off as everybody. They only had to fire and lay off a ton of people once the space shuttle program wrapped up, but they didn't have to fire everybody because now they could have them all working on the next rocket system and have the people who worked on the International Space Station work on the Deep Space Gateway, right? Like there is some NASA involvement in every single state in the United States. So these are voters, and these are people who can kind of rile up and put pressure on Congress. So that's a lot of the reason why these programs are developed the way they're working. So anyway, I'm so jaded.
I'm going to echo what one of the YouTube commenters, Kurt Riber, just said, which is moon, Mars, whatever, let's just get something done.
Well, I love what Daniel
Echo that
McCool said.
comment.
Daniel McCool said, my thought is stop arguing about a destination, pick one. That's it. Don't make me turn the space program around. Which I think is just perfect, right?
I will turn this space program around.
Yeah. So anyway, obviously we'll, once there are details, I'm sure that'll be a segment here on the Weekly Space Hangout is where we discuss the actual development. But here we go. All right. Well, now it's time for the interview. And then chat can just cut out this part. And now we're going to return from the interview. Don't go anywhere, Kimberly.
It's all right. I was just refreshing my webcam. Internet was wonky for a second.
All right, well, that's it for the Weekly Space Hangout for this week. We still need your recommendations on how we can close this show. So if you've got some ideas on what we can do, please just comment on the video or send me an email at fraserkane@gmail.com and I read them all and I'll propose them to the team and we'll come up with a way to actually to wrap this up. Thanks to everybody who sent me comments, and I've gotten back to all of you. Yeah. All right. So Kimberly, tell me what you're working on. Tell me where I can read some of your writings.
Sure. So right now I am working on a story about the possible effects on science and the scientific community for resulting from the proposed travel bans to different countries around the world. So sort of a depressing thing, but a very important topic for science and scientists all around the world. And so that's what I'm researching right now. and working on, and you should be able to read that in probably about 3-4 weeks time on eos.org, eos.org. That is where you can read all of my writings.
And of course, Astro Kim Cartier.
And Astro Kim Cartier on the Twitter, and kimberlycartier.org whenever I get around to updating that.
All right. Paul.
Yeah.
Tell me a cool project. Shamelessly self-promote something that you're working on.
I'm kind of working on an astronomy-themed cruise to the Caribbean.
Tell me more.
Hey, guess what? You're going, Fraser.
I know.
You want a trip? No, yeah, astrotouring.com. Fraser and I are back on the road and we're hitting the waves. We're taking an astronomy-themed cruise to the Caribbean. We're going to Mexico. We're going to Belize. We're going to Honduras. We're going to do stargazing. We're going to do talks on board. We're going to have a lot of fun. It's a great excuse to take a vacation and with other people who love astronomy and get to hang out with me and Fraser and just talk with us all the time.
Yeah, we're going to do live events of our various shows. I'm going to make a couple of episodes of The Guide to Space. We're going to teach you the night sky. We're gonna
check out Mayan ruins.
We're gonna go to the Kennedy Space Center and like check out rockets and the space shuttle Atlantis, which is always a treat. So, and if you, I mean, it's like if you're already planning on doing some kind of vacation with the family, come with us. We're your family.
It's pretty cheap. It's a very affordable trip, and you just need $25 to get your name on the list, and then we'll figure out the rest of the money later.
Yeah,
$25 just to reserve your spot. That's astrotouring.com.
Yeah, and that's the key. Just put your name in there, and that way you just got a spot reserved, and then later on, when all the spots run out, you're covered.
You won't be sorry.
Well, you know what? That's going to be the thing that I will also shamelessly self-promote is this astro touring that I'm going to be doing with Dr. Paul Matzetter. So, yeah, absolutely. Go check that out. What's that URL again?
Oh, good question, Fraser. It is astrotouring.com.
Perfect. All right. Well, thanks as always to everyone. Thanks to our special guest this week. A big thanks to the WSH crew for setting up, running the chat, and really kind of being the heart and soul of everything that we do. So if you want to be a part of that community, go to wshcrew.space. Now I'm going to put us all up in the three of us. Oh, and Morgan, we miss you. We'll see you next week.
It's Morgan. He's much taller than me.
He is surprisingly tall.
What's up here?
All right. So now you guys are free. Go ahead and stop your recording. But we're still live. And now I'm going to play the interview.
All right.
All right.
Have a great week, rest of the week, everyone.
All right.
See ya.
I'm going to stop my recording. And they're going to go. And then I'm going to put up the episode. Buckle up. Like I said, I kind of got into it. So here we go. All right. So our guest this week is Chris Profit. Chris has written a new book called SpaceX from the Ground Up, and I think this is very well timed. Chris, welcome to the Weekly Space Hangout.
All right. Hi, Fraser. Just nice to be here, meet you finally. A little correction. I have first published this book March of last year, about 6 months before they did the original IAC presentation, giving a few views of what some of the things they will be presenting. Some good, some surprises there, but this is the 4th edition where I'm fully up to date with the 2017, which I'm just preparing at the moment. So yeah, it's
that's
great
so
fun.
funny, right? Like in the normal world, to have written a book within around a year of some newsworthy event, that is a new book. That is a book that is still, and the fact that you're having to be up to your 4th edition on a book because the news coming out of SpaceX is changing so rapidly, I think is quite telling on sort of the state of the industry and the state of just really how quickly Elon Musk operates. So why don't you give us some more information just about the book? What sort of led you to write this book about SpaceX?
Well, I've been writing sci-fi for quite some time now. I'm happy with what I'm doing, but of course you need a lot of research, keep current with what's going on in science and space and whatever. And every time I go online and I'll be researching something, and SpaceX would just keep cropping up with increasing frequency. You know, they seem to be more centered to what's the future of space, really. So delved a little bit deeper into it. A few posts that seem to be well received, and then the big question is where were they going to get the money to build it? So I like to analyze stuff. Went away, looked at all the problems, all the possibilities, and in the first book, I sort of said, well, they can do it themselves. Now, that was 6 months before they did the IAC 2016, and basically that was a big sales job for NASA, saying, look, this is what you really need to do colonization. NASA looked at it, and I believe they spent so long with it, they actually delayed the actual public presentation of this. So because they just wanted to keep going over the fact that it's really 12 meters diameter. It can really put 450 tons on Mars. But it's funny because it's sort of come full circle. They've sort of put the hand out and said, look, anybody wants to help us with this. They've had a year. Nobody sort of stepped forward in a substantial manner. I mean, NASA's been helping them behind the scenes lots, especially with the Red Dragon, selecting landing sites with JPL. But nobody's come forward in a major way. So essentially, they've sort of defaulted to what I suggested in the book, which is we can do it ourselves. In some ways, there are a lot of advantages to that, because if you sign up with somebody else, well, immediately you've got two hands on the steering wheel. Whereas if they do it themselves, they just do it how they want to do it, the best way they see possible. That may be the best way in the end or not, but they're going to find out on the way, as far as I can see. You know, it's all good. Yeah.
So I know in your book you talk about sort of the past and the future of SpaceX. So let's spend a little bit of time on the past and then spend a lot of time on the future. So where, from what you're reporting, how did we get to where we are now with the company?
Well, I mean, Elon probably don't want to bore too many people, but he came out of PayPal. He was one of the PayPal mafias and the original founders with quite a wedge of money. And instead of just retiring, because he wasn't even 30 at that point, he said, well, I feel I should be doing more, really. There's things that should be happening in this world, like we should be on the moon, we should be on Mars. And so he goes on NASA's website, has a look to see their plans, and there are none. So he thinks, well, okay, let's try and help NASA. Also, just need more money. It's just a cash question of money. So he goes out, looks around, tries to buy some rockets, and the price in America was just off the chart. And the cheapest ones were in Russia, but he negotiated, I believe, 27 million for 3 rockets, and then he came back with a big case full of money, and then he said, oh no, it's 27 for 1 rocket. And I go, oh. So he got back on his plane, and then on his way home showed his team of advisors, well, look, we can do this ourselves. He got a spreadsheet already worked out as a contingency. Let's do it ourselves, make our own rocket, and we can make it so much cheaper than anybody can do it at the moment. And that's where we got to, really. That's where it all started, I think, the nucleation. Yeah. And he's right. The components are just like 2% maximum. As he puts it, if you find a magical way of taking all those elements and making them into a rocket shape, it's just 2%. Now, they haven't quite got down to 2% for building the rocket, but it is still very, very cheap. I mean, you've got to remember, back in 2002, the American launch industry, there was no commercial launch. It was just so expensive. It was all going to Ariane and Soyuz and maybe heading towards China. But he said, okay, well, look, we can make these rockets a lot cheaper, and they can be reliable. Let's do it. And that's essentially what he's done. He's just, they're likely to, I think they've launched more rockets than anybody else, any other commercial entity in the world so far this year. So, that isn't down to the fact that they've got a great sales team. That's just down to price, basically. Well, primarily, there's a lot of other things going on,
Yeah, no, I know when the announcement, he said they did 16 launches in 2017 so far, and I think they're planning to do 30 next year, which is just.
I believe it's 21 they're aiming at now. For this
right,
year.
17 so far, with 21 by the end of the year, and probably 30 next year. So it's just a ridiculous number of launches compared to anyone else out there.
Oh yeah.
So then let's talk about the future. I mean, I know that sort of when this interview is going to be going live, we will have already talked about the big announcement in the Weekly Space Hangout last week. But what was your sort of perspective on this big announcement of the BFR?
Realism, really, I think, is the best expression of it. I mean, the previous incarnation, the ITS that they presented at the IAC 2016 last year, it was just, it was literally out of this world. I think NASA looked at it and just said, well, we can't quite believe this. It's just so much more capability than we've ever seen before. It's like 42 engines and 450 tons to Mars. Yeah, maybe you're talking about a rocket 100 years from now, but we're not quite convinced. But this year, they came back with a slim down rocket. Yes, it's only 9 meters. I mean 9 meters wide. That is still huge.
It's ridiculous.
Right? It is ridiculous, and it can still do 150 tons to Mars, which is usable. It does have some big advantages because you look at it. All of the SpaceX rockets are skinny rockets. So you look at it and you think, oh well, that's, that is like the rockets they have at the moment. It's very sort of real looking. You can imagine it actually working. It's got 31 engines on the base, another 6 on the second stage. It's looking like a factual, practical rocket, and I'm quite impressed with it. Yeah, they've actually got some big advantages. Like previously, something I sort of pointed out in my book, if they just sent one colony vessel to Mars, if that colony vessel had any sort of problem at all, then that's it. So essentially, the lander is more important than individual lives. People have to sacrifice their lives to keep the lander going. Whereas with this one, they're sending multiple colony vessels, and we don't know whether they're being able to be used as cargo as well. So there's a little bit more leeway. So people come first, which is important because you can't replace people. They're absolutely, invaluable when they're going to be on Mars. You spend all that way, they're fantastically trained. They've got to protect those people, and that's exactly what they've done with the new plan. They've given themselves a lot more bandwidth to take people to Mars, which is great.
Now the plan is that this rocket is fully reusable, both the initial booster as well as the spaceship upper stage, reusable in every capacity, that they can dock in orbit and refuel. They can land again on Earth. They can be used for point-to-point transportation here on Earth. That sort of full reusability. I mean, we've seen the booster reusability, so we feel like, okay, maybe they've got that under control. But that full reusability is groundbreaking at the next level. And do you think that they've got that under control?
Well, space breaking may be a better
space breaking
term.
Yeah.
They are certainly getting there. I mean, Elon said it himself. They've got that supersonic retropropulsion down. They've got an X marked on their landing ship, and landing on ships is one of the most hardest things to do. According to Navy pilots, it's way harder than anything else, and they are dropping it right there. X marks the spot. That has to show that the algorithms they're using are just spot on. And I'm just, I'm sort of salivating just thinking about how it's going to work on Mars, because that's going to be the real challenge. But the ship, as you say, it can go to the moon, it can go to Mars, go to Jupiter moons. You can use it point to point. It's one rocket to rule them all, really. It's the answer to our sort of space problems, as far as I can see, and it's very well put together.
Now, he said that the cost of this rocket is, because of its full reusability, is going to be down below the cost of the Falcon 1 in terms of launch costs. Is there any idea what the sort of cost per kilogram is going to be with the BFR?
Cost per kilogram to orbit.
To orbit, yeah, even just to low Earth orbit. Like, if it is the cheapest thing out there, how cheap?
How cheap? How cheap can it be? Wow. Well, it all depends on how many uses they get out of it. This is the thing. It's the old rocket equation it's just out. You know, it fires once, that's it. How many uses you get out of it, and what the cost of the fuel. In theory, if they can, they didn't give any indication on the number of reuses. I mean, prior they've sort of been saying 10, 12 for landing on Mars and then bringing back to Earth. All depends on the application, but my guess would be relatively high.
Yeah, I saw in their expectation was sort of in the hundred range. But
yeah, especially for the booster. The booster is very sort of low stress. Really, it just goes up and it comes down, and that's it. Whereas the the actual spacecraft, the lander, that's 5Gs going in on Mars, and it's a little bit gentler coming in on Earth because you can do a shallower entry and this just bleed off all that excess speed at a high altitude, so you don't need to decelerate so hard and use your engine so much. But I think the cost, realistically, because of the high number of uses, is down to the fuel. And the fuel, he hinted at a unique solution to the cost on the fuel during the presentation. And that is the fact that the ISRU system they use, it isn't like magic that only works on Mars. They can make it work right here. So, I mean, say they wanted to do that like point-to-point venture where they just put a large sort of barge offshore from New York. Cost of the fuel, all that fuel could be manufactured using solar cells and an ISRU plant. All they need is water and carbon dioxide.
Right.
Carbon dioxide, you squeeze out the air, water's right there. So you're talking about, as soon as you've written off the cost of the plant, you're talking nothing for the
it's crazy, right? So you just got this plant sitting right beside the rocket. It's using solar power to pull in water, carbon dioxide, make the fuel, refuel the rocket. The rocket's already paid for. The fuel is essentially just coming right out of the air using solar panels. Like it's mind bending. And like I'm always just like torn. Like on the one hand, Musk has delivered us just science fiction Christmas, and then on the other hand, I have a healthy skepticism. So we'll see how this plays out. Their rockets do land on the launch pad. So no matter how skeptical we want to be, we can watch those rockets land. Let's talk about the future. The sort of anticipation is that the first mission is going to go in 2022. The first humans are going to go in 2024. Let's say the rocket does get built and the rocket works and it does its job just great and it is capable of taking people to the moon. It is capable of taking people to Mars. Have the details of living on Mars been worked out sufficiently that Mars is ready for people? Like, where are people going to go to the bathroom? What if they run out of spare parts? Can people handle the gravity? What about the radiation? How are they going to eat? Like, it just, like, the list of when I think about what it takes to just live here on Earth, they have to replicate that on the surface of a place that is incredibly hostile to life. So do you think that the actual colonization efforts are in line with the rocket efforts?
Yeah. I mean, I have dedicated a whole chapter to this, basically. Elon isn't just one to sort of be laser focused on one thing. He likes to, keep a wide view on everything. I mean, Tesla Motors, for instance, they're not going to worry about having surface transport. The Tesla Motors is actually on the campus at Hawthorne, which is where the factory is for SpaceX. So it's just a walk across the road. Can you make this up? Okay, that's fine. So habitats, it's very interesting. He's talking about habitats which are carbon fiber frames with glass. That's exactly the same design as what they intend for the ITS as it was and the BFR as it is now. So they're saying we'll make something exactly the same as the rocket, but a dome, and something we can disassemble, put inside the BFR, wheel out. So that's fine. I know they've reached out to a group in Arizona to talk about sort of a closed loop ecosystems, and that group said that they've spoken to somebody else as well. So they've sort of, they are taking things in hand behind the scenes. It's not been forgotten about. No, certainly. I did hear during the week they're actually trying to do some nuclear research as well, because obviously there's like dust storms on Mars, and all those fantastic solar rays they're going to have are just going to be useless for anything up to like weeks or even months. So yeah, you can have some big energy storage device there, but sooner or later, if they have a huge energy footprint, maybe 5 or 10 times more than us on Earth, they're going to need, serious power, which is nuclear. I mean, the only problem they got so far is they said they're having a problem finding people who are willing to give them nuclear materials.
Yeah,
so,
sure.
So I don't know how they're going to get over that, but
yeah, yeah. I mean, it again, just the mind boggles at the details required to actually do this work, but. The other option is you just send a bunch of people to the surface of the red planet and let them figure it out. With the like the Martian, like they've just got, they got what they have to work with. They're capable people. As long as you send them a lot of raw materials, they can sort of build, and especially with 3D printing and things like that. Like there are
Exactly.
possibilities to build things on site that maybe we haven't thought about, and we can send details and stuff from Earth. So there's still going to be communication back and forth. So what should people be watching for, sort of as the next part of this to unfold? Falcon Heavy, more reuse of the Falcon 9, first test launches. Like what comes next?
Okay, well, they're getting somewhere when they decide to discontinue production of the Falcon family, because that means they've built up a sufficient stock of reusable rockets, and they're just going to, and they've basically burnt the boats. They're saying, okay, we can see BFR, we can actually have a chance of building it in a certain time frame. We've allocated ourselves a certain amount of rockets that, well, once they've sort of start reaching the end of their life and we have to red X them, then we have to have BFR ready. And, that's just both a stimulus and a way of encouraging everybody at SpaceX and outside, saying, well, look, we are really serious about this. I mean, he's done it before with roadsters at Tesla. He says, look, roadsters fine, but we need to be moving on to the Model S now. And the same with the Falcon 1. Falcon 1 does its job. We've got Orbcom wants to launch on it as soon as we've finished our mods, but no, we need to be moving on to the Falcon family, Falcon 9, Falcon Heavy. So poor old Falcon 1 got the chop. But I mean, it's sad because, I mean, we're used to seeing programs sort of half go through and then cancelled, like Apollo and Constellation. And then when you hear cancelled, you think, oh no, that's terrible. But these programs have actually reached the fruition of where they wanted to go with it. They've learned everything they can, and now they're taking that knowledge and going on to the next stage, producing BFR in this case, which is a very, very serious piece of kit. They are very serious about space, although they still like to have fun with it.
Yeah.
Yeah.
So I've got a couple of questions from the fans here. So this question comes from Arjun, which is, do they worry about inoculating Mars with Earth bacteria before NASA can send scientists to fully study the surface? Are they working with NASA on this? So this idea of planetary contamination, which came to light with the crash of Cassini, there are concerns about humans contaminating any kind of life on Mars. Is anyone trying to stop them or put some sort of limits of where they go and what they do on Mars?
Well, I believe NASA are surprisingly liberal in this regard. I mean, they have to have oversight according to the OST, the Outer Space Treaty from that's been set up from back in the 60s. But that's UN had a vision then. How much it applies now, probably less so. But planetary protection, it's just basically about mitigation, trying to reduce the risk. I mean, NASA have people in-house, and they tell their mission programmers, the builders, this is what we want to do. and they try and reduce the amount of load on their landers to a certain number of 100 particles, spores per square inch. But you never get rid of it entirely. And NASA's vehicles have driven past, wet areas, linear as they describe it. It's possible it's already happened, but it's just reducing contamination. The only thing is you send people there and you just cannot. They are just, well, they're dirty meat bags basically, and things are gonna cross. If there's a chance, they'll cross. But to be honest, the surface of Mars just looks like completely blasted with UV. It's so cold and so much UV, you just can't imagine anything existing. Yes, in the first billion years, it looked probably a better place to live than Earth, but right now, maybe not so much. So there might be very much like the moon, I'd have thought, when they get there, but I'd be pleasantly proved wrong, hopefully.
Right. And so this question comes from our intro. Reusable rockets boosters were long thought simply impractical. What was it that allowed SpaceX to develop this technology where others saw only wasted payload space and unnecessary complications? How come nobody tried to build a reusable booster before?
Well, I mean, they did try reusable stuff. The shuttle was tried to be reusable, and DCX, they tried, but things for various reasons, I won't go into it, but the things fell by the wayside. Elon is focused, and the people he works for is focused. He's got a reason to do this. He has to do this to make space, democratize it, to allow everybody to go to space, whether it's just a flight from New York to Shanghai. They can have a diploma that says astronaut at the end of that because they've been to space. It's got to be reusable because it's mad. It's the only form of transport pretty much which isn't reusable. And as we discussed, as soon as it's reusable, you can get the cost down. We're not sure how far they can get it down. The only limit we know is 0, right?
Yeah.
It had to be done. If you want to get to Mars or the moon or wherever, you have to do reusable. And I mean, typically, I'll give you an example of one of the things they did after they just completed the Falcon 1, and it was happy, and everybody was happy as flying. It was a great vehicle. Elon went down to Tom Mueller, the chief of propulsion there, CTO of propulsion, said, "Well, look, we need another 60% of thrust out of it." And he goes, "We've just got it working, 60%." He says, "What for?" He says, "Well, we've decided we need to put on extra 60% of fuel so we can turn it around and fly back because we can't parachute it in the ocean. It's hot metal parachuting into the ocean. Can't get the parachutes to deploy, and even if they did, it'd just be rubbish we got out there, dug out of the ocean, right?" So they went. So Tom says, "Well, that's just almost impossible to increase the thrust in the engine. We'd have to strip out every control valve in it and just have it directly fed from the turbo pump and controlled at the face of the injector." And Elon says, "Right, do that."
Sounds good.
Just do that.
Yeah.
So they went away and they blew up a hell of a lot of hardware, but they got it to work, and that gave them extra 60% thrust, and they carry an extra 60% fuel, which allows them to turn the boost around and fly it back to the Cape, which is, dangerous. It's just so dangerous doing that whole thing. I mean, Tom Mueller was like, break down at one point. He blew up 2 engines one day, and Elon just said, "Well, just calm down, call it a day, and tomorrow you can come back and start putting together the test stand," that sort of thing.
You can blow up some new engines tomorrow.
Yeah.
Well, Chris, running out of time, so we've got to wrap this up. But man, it's so great to talk to you, and it's a funny time. We're right now in this twilight zone between these crazy promises and yet these landing rockets. So I really look forward to what's going to happen, how things are going to unfold over the next couple of years. So please keep us, on top of what's happening. Let us know when the BFR launches.
2022.
2022.
That's when I say it'll launch.
So where do people find out more about what you're doing?
Oh, well, I'm on Amazon, and if you want to visit me, I'm always on SpaceX Reddit. we have a good chat about a thing or two over there. If ever you got an idea about SpaceX, put it there, and you'll soon find out whether you're right or not.
That sounds great.
Okay.
All right, Chris. Thank you so much for joining us on the Weekly Space Hangout. And
It's been
and good
lovely,
luck with
Fraser.
good luck with the 5th edition and the 7th edition of the book. I'm sure they'll be coming out soon. We'll see you later.
Okay. Cheers.
All right. And now it's actually me again. All right, so that's it. Thanks, everyone, for watching the Weekly Space Hangout this week. Thanks to the co-hosts who have long since gone. But, yeah. All right. We'll see you all next week. And thanks to Chris Prophet for handling all of my questions and some of your questions. So, see you later, everybody.